So I was looking for a way to manage sort of all of my Web 2.0 sites recently. Twitter, Seesmic, FriendFeed, Laconica, and first I found Twitterrific, which is nice. It costs money, but it's nice. And I found Jaiku, which or Yoo-hoo with a J for Jaiku, which is also nice, and it's free and open source. But the problem with those is they only work for Twitter, and the other one only works for Jaiku. And the only one that really works for all of them is Twirl. But Twirl is written in Adobe Air. And for those of you who don't know what Adobe Air is, it's sort of like Flash, but for the desktop. And that means that it can run on Windows, Linux, and OS X without having to rewrite the application. The problem with that is it doesn't really run or look natively on any of them. So if you run Twirl, it's always in your dock, and I would prefer it not be. I want it up in the menu bar, like Twitterrific. But apparently that's a limitation of Adobe Air that the developers haven't figured out how to get around yet. So I figured instead of complaining, why not write my own? So that's what we're going to do over the next few weeks on Hot Cocoa, with probably breaks in between for other topics. We're going to learn how to access different APIs on the web. We're going to learn how to post stuff back to like Twitterrific, or to Twitter. And we're going to learn how to save passwords and make panels and do skinning and all that stuff. Coming up on Hot Cocoa's 7, 8, 9, 10, etc. The first thing we need to do to get our Twitter app up and running is to take a look at the Twitter API and find out how we can call the specific things that we need to call in order to get the data that we want. And we can look at the Twitter API documentation by going to apiwiki.twitter.com, and we want the REST API documentation. And REST stands for, there we go, Representational State Transfer. And what Representational State Transfer is, it's a long and complicated name for something that's actually really simple. It's basically the same way that HTTP works, where you send GET and PUT requests, or GET and POST requests, to send and receive data from, in this case, the Twitter server. And then API stands for Application Programming Interface, which basically just lets our applications interface with Twitter's online applications. So what we want to get is the public timeline, which if we look under the status methods, here's their public timeline. And you'll see it returns the 20 most recent statuses from non-protected users who have a custom user icon. And it does not require authentication. And here's how we get it. And we get it by sending the method get to this address here, and then specifying what format we want it in. And we would like it in XML format. And this is basically identical to what would happen if you just pasted the address into your browser and then hit enter. It'll send it a GET request, and then it'll send us back the XML data, which is precisely what I've done over here in Firefox, because it formats the XML nicer. And you'll see if we actually if we send a GET request to that address, this is what it'll send us. And this is in XML format. So we have our main node here, which is called statuses, and it's of type array. And then under statuses, we have all of the individual tweets, which are made up of status nodes. If you expand one of the status nodes, you can see that it has created at, the ID of the tweet, what text the tweet contained, and then down here it has, within the user node, it has information about the user, like their username, their screen name, their ID, stuff like that. And the way you can think about this and how we're going to be accessing it is it works as sort of like a file path. So, for example, if you want to get the username, like their username right here, what we would go to is statuses/status /user/screen name, or name rather. And if you wanted the screen name, you go to statuses/status/user/screen name. And what that's called the XPath. And we're going to use that XPath to load the data about each of the individual tweets into a table view. So now we can go ahead, now that we know what the server is going to send us, go ahead and start writing our application. And we'll make a new project. Go application. And let's call it tweet app. And we'll go ahead and go right into the interface building. So we have interface builder all loaded. And let me clean this up a bit. There we go. And what we're going to need here, we go into our library. We will need a table view. There we go. And we'll stick that right around there. And we'll need a button. And I'm going to use a rounded rectangular button for reasons you will see in just a second. And line those up nice and neat like that. Like so. And we're going to need a progress indicator, which I will stick right here. There we go. And finally, that's all the objects we'll need for now. I'm going to change the look of this window to textured, because I think that looks nicer. And let's see, that. And it looks better down here. So we need to name our button, and we'll call it Get Public Timeline. That's descriptive enough. And what we're going to get is the username of the person who sent the tweet and the text of the tweet. So that's what we'll name our columns there. And then within these, each of these columns has an identifier property. And within that identifier property is where we're going to store the XPath that we want to get that data for. So for username, if you'll remember, the username is under statuses/status/user/name. However, once we parse through the XML data, what we're actually going to end up with is an NS array containing each of these status nodes as an object. So we only need to include the part after this status. So we're going to set that one to user/name. Go back into interface builder. Set that to user/name. And likewise for the text. Since text is directly after status, all we're going to do is set that to text. There you go. And just a few more interface things. I want to set the auto resizing for that so that it stretches on all sides. Like that. We want to set the auto resizing for our little circular progress bar so that it follows that bottom right edge. And we can save that. Oh, and one more thing with this. We need to change it so that it doesn't display when stopped, otherwise it'll always be there. And we only want it to pop up when it's actually spinning. So we'll go ahead and save that. And close Interface Builder for now. And I'll minimize that. And we will head back to Xcode. So now we need to create our app controller, just like usual. Create an Objective-C class, call it app controller. And I'll move that up into here. And within our app controller, we're going to need 2 outlets and an action. So we need 1 outlet for the NS table view. And we'll call that timeline view. There we go. And another one for the NS progress indicator. And we'll call that progress. And then our action that we need might be action get public timeline. id sender, and there we go. And we'll go ahead and save that. Go back into Interface Builder. And now I can link these things together. So we're going to need to add our object. That will become our app controller. So we'll drop that in there. Change its identity class to app controller. And there are actions and our outlets, so we know that worked. And then we'll just go ahead and link them like usual. Link that. And link the button to the action. And then, let's see. Yeah, it's going to be a little difficult to get to. Let me move this out of the way. And we'll link up that. There we go. So now our interface is done. We can save that. And close Interface Builder. Actually, there's one more thing that we need to do. Open up Interface Builder again. We need to set this table view to use app controller as its data source. And if you click on the table view here and make sure it says table view up here, and we go into its connections, one of its outlets is data source. And what that's going to do is it's going to tell the table view that we're going to implement two methods, which we'll see later. And what those methods are going to do is it's going to feed the data to the table view when it requests it. So it'll say, you know, what do I put in this row in this column? And that's what our methods that we're going to write in a second will tell it. So we need to click and drag that to app controller. So that says app controller as its data source. Go ahead and save that. And now we can quit Interface Builder. And there is two more things we need global variables for here. We need an NSXML document. And we're going to call that timeline XML. And we need an NS array. And we'll call that statuses. And basically, the XML document is going to contain a formatted version of the data that Twitter is going to send back to us. And then our NS array, as you said earlier, is going to contain an array of each of these status nodes here that contains the tweets. So we'll switch over to appcontroller.m here, and I'll go ahead and paste in the code that we're going to use. So I've gone and pasted the code in here, and it's sort of a lot of code. So I would recommend, instead of trying to copy it from the screen, just to go to the blog post and download it from there, and then follow along, and I'll go over what each line does. And the easiest way to do that is I'll run the application, and then I'll tell you what it's doing while it's doing it. So the first thing that happens is when we click the Get Public Timeline button, it runs our Get Public Timeline method here. And the first thing that it does is starts the animation or little progress spinner, which we set to not display when it's not there. And you'll notice if I click it again, the reason it's not trying to reload it is because it's cached. And I'll talk in a second about how that works. And the next thing we do right here is we need to build up a URL request. And then once we have that URL request built, we're going to create an NSURL connection, which will then connect to the Twitter servers, send our request to the Twitter servers, which will then send back the data that we want. So right here, first we need to build or make the URL request. So we set our Twitter address here that we got from the API, set that as an NS string called URL string, and we then load that string into an NS URL. And after we do that, we then take the NS URL and load that into an NS URL request. if we take a look at some of the options here for creating an NSURL request, see we're creating an NSURL request with the URL, which is we get from here. And then we have our cache policy, which is request return cache else, or request return cache data else load. And you can look in the documentation, there's a couple of different cache policies. What this one does is it checks to see if there's any new data. If there's not, then it doesn't bother to re-download it. It gets it from the cache. And then that's why it reloads so quickly. And then the timeout interval, we set to 30, and this is in seconds. So after 30 seconds of trying, it'll give up and say, I can't connect to the server for whatever reason. And then after that, we're declaring some variables here, or some objects rather. And we make an NSData object called URL data. And that's where we're going to store the raw data that's coming from the Twitter servers before we put it into a nice, neat NSXML document. And then we have our NSURL response. And that's where we're going to store the response that the server is going to return after we send the GET request. And basically what that is, it's a number telling whether it went okay or not. And like, for example, 200 means it went okay. As I'm sure you're probably familiar with, 404 means the file doesn't exist, and 403 means you're not allowed to access the file. So that's what the NSURL response is. It's that code. And then we have our NS error, which basically means if it can't connect for whatever reason, it'll send us that error. And then down here, I have some code that I've collapsed here just to make it neater while I'm explaining it. This section here is basically just error checking. It checks to see if URL data actually exists, and then if it doesn't exist, it pops up with an error telling us what happened. So we always want to make sure our data actually exists in the object before we try and do anything with it. And then down here, this is memory management. We want to release the timeline XML document before we alloc another one. That way we don't end up with a memory leak. Since we only need one of them at a time, but it retains it because we need it in more than one place. So we have to manually release it before we alloc a new one. And so down here we allocate and initialize, in this case with the data that we got from Twitter, our NSXML document that's called timeline XML. And then again, this is more error handling code here. And then we set up our NS array, which we name statuses, and again we want to release it first so we're not leaking memory. And we use the method nodes for XPath from timeline XML. And what that's going to do is that'll return us an NS array with whatever we put in this path. So as you'll remember, if we looked at the XML code, we have multiple status nodes, and we want to load those into the NS array. So we're going to use our XPath here. Like I said, it's a file path, statuses/status, and it's going to take the nodes from that XPath and load them into our statuses array. So we'll end up with an NS array, and each object in the array is going to be one of those statuses. And then again, we have more error checking code here, make sure status actually exists. And then right here, we reload the data for the timeline view and turn off the progress indicator, which makes it go away. Now what happens when we reload the data for the timeline view is the timeline view, our NS table view here, actually calls two methods, which we've implemented down here. And you'll notice we didn't declare them up here back in our header file. And that's because they're already declared for the NS table view. We're just overriding them so that we can provide the data for it. And anytime you set up your own object as a data source for NS table view, you're going to need to implement these data source methods, so that way it has someplace to get the data from. So the first thing it calls is the number of rows in table view, and then it'll tell us what table view is actually requesting that. and we're going to return the count of the number of objects that's in our status array, which is basically the number of tweets that we returned from the Twitter servers, which, if you remember from the API, was the first 20 from the public timeline. And then after it knows how many rows to make, then it wants to know what to put in the rows. So to do that, it's going to call the table view object value for table column row method. And basically what that does, it tells us what, first it tells us what table view is actually requesting it. And then in this argument here, it'll tell us which column it wants the data for, and then which row of that column it wants the data for. And this is where we have our NSXML node. And that will return us, we're going to grab one of the tweets, one of our status nodes from our NS array that we made, and load that as an NSXML node. So what's going to happen is we're going to get the object at index row. So say it wants to know for row 1 what to put in row 1. So it's going to tell us we want the object at index 1 from our array, which would be, if we go into here, that's going to be this second status node here, because in arrays there's 0, they start with 0, so they count 0, 1, 2, 3, etc. So 1 is actually the second object in the array. So that'll return us this node here, and that individual node is going to be put into this NSXML node called node. And then we want to know what part of that node that we want to get. And you'll remember way back when we were setting up the interface, we set the table columns identifier to the specific XPath of the data that we wanted to get from that node. So like for the username, we set it to user/name. And this will take the table column that when the table view called this, it told us what column it wanted it for. So we're going to get the identifier for that column and set that as an NS string called XPath. And then what we're going to do is we're going to call another method that we wrote called string for path XPath of node. And that up here, this is what this is here. And if you'll notice, the way that's going to call it is going to call it string for path, and then tell it the XPath that we got from the identifier, which for this case would be user/name, and it's going to tell it which node it wants that from. So which node in the index that it wants that from. And that passes it up into here, where we then create an NS array called nodes. And that's going to get the nodes for the XPath of the XPath that we create, or the XPath that we set in the identifier here. And what that's going to do is, if we look back in our XML code, it's going to create an array of all of the things from that XPath, which in this case there's only one thing. So there's only going to be one object in the array, because the only thing in this XPath is name. But for example, if we tried to, if we set the XPath to just user, it would end up creating an array that contained the ID and then the name and then the screen name, etc. But in this case, because we specified just the name, it's going to only have one object in that array, and that's going to be the name. And then from that array, this is more error handling code that I've collapsed here. And you'll see if our array for whatever reason doesn't create it, show an error. Likewise, if there's nothing in the array, then return nil, so it doesn't try and load from something that's not there. But if there is stuff in the array, which we hope there is, it's going to return from our array the object at index 0, which is the first one, and it's going to return the string value of that, and it's going to take that string value and then put it in that row for that column. Now, say for example, like I said earlier, if we instead of having it directly set to the name, we instead took the XPath for user, and it made an array of the ID, the name, the screen name, etc. Say, for example, we wanted to get the name. Since it's the second node in this array that we just created, we would call, go back to Xcode here, we would call object at index 1 because it's the second one. Likewise, if we called object at index 0 and we didn't specify that we wanted it from the name, if you set it to user and we made an array of all of this, 0 would be the ID, 1 would be the name, 2 would be the screen name. But how we have it set up is we set it to just go directly to the name. I only want one object in the array, and in which case it'll be the first object, which is 0. So it'll return the string value for that object, which is the username. So that's pretty much all that it does. So just to review, we create our NSURL request. We send that URL request using an NSURL connection to the server. It sends us back URL data, which we then put into an NSXML document. We then take the nodes from this XPath, statuses/status, and put them all into an NS array. We then update the table view here, which runs the number of rows in table view, which tells it how many rows to make. It then runs the object value for table column row method, which we then, from that, will call string for path of node, which then loads the nodes from the XPath that we specified in the identifier into an array, which in this case there's only one object in the array because we only specified one node, and there's no subnodes under that. And then from that we get the string value for that first object in that array, which then gets set to either the username or the text depending on which column it's selected. So this is sort of, it's a lot of code. It's a little bit complex, so hopefully I've explained it in a way that makes some sense. But if you need more help, as always, you are welcome to join us on the forums under the thread for this episode and ask any question you want, and I'll try and clarify anything that you need help with. Coming up on next week's Hot Cocoa episode, we're going to take our Twitter application and we're going to make it so that we can get the friends timeline. And in order to do that, we're going to learn how to create a panel, which is one of those it like drops down. It's like if you try and close something without saving it, it's what pops down saying, don't save, cancel, or save. That's called a panel, and that'll drop down. And we're going to make a custom one of those that'll ask the user for their username and password. And then we're going to learn how to save that username and password in the keychain. And then we're going to learn how to add that to our GET request so that we can get not only the public timeline, but the person's friends timeline. So that's coming up next week. See you all then.